Satu, dua, tiga, dicoba C. C. Satu.
Ayo masuk-masuk yang masih di luar. Baik, selamat pagi. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi semuanya. Jadi alhamdulillah di pagi hari ini kita kedatangan tamu spesial. Ya. In this morning we have special guest from Luxembourg. I think you will get some special lecture today from Dr. Mehdi from Luxembourg Institute of Science and Technology. He like to talk about integration of soil Saprolite Continuum in the relation with the soil classification. Maybe you talk with soil taxonomy or my WRB. Yeah, okay. I think Dr. Ma'ruf already teach about the soil classification for undergraduate and master student. Also, welcome, ahlan wa sahlan, bi khudrikum, the family. Okay. Ayo, masuk. Come on. Okay, for this time, I think the time I give you, Dr. Mehdi, to give this lecture. Okay. Thank you.
Assalamu alaikum. Assalamu alaikum wa salatu wa salam ala Sayyidina Muhammad wa alihi wa sahbihi ajma'in. First of all, I'm very glad to be here in front of you, all of you students and professors. It's a great pleasure for me to be here and to visit your country. You are nice people. I'm here with my family since some days, and we really enjoy to be in Indonesia. And I would like to thank, of course, Professor Mahouf first, and all the other professors for this great place and great moment with them. So just quickly, I will present myself. So my name is Jérôme Juilleret, but I took Shahada 20 years ago. So my second name in Islam is Mehdi Abdeslam. And I'm married with a wonderful Moroccan wife, and we have 2 daughters. I am working as engineer in Luxembourg. And I'm in charge of critical zone observatory. So we are dealing with data of the environment. But my specialty is more soil classification, because I am part of the working group about WRB. So I attend most of the time the excursion of the WRB. I was in Iceland last year. I was in Mongolia, in Estonia, in South Africa. I have seen many soils all over the world, and I also participate to the WRB new edition. And now I will speak about the gap between the soil classification, the real soil, and the rocks below. So I will start the presentation. So in fact, this presentation, I made it already, so I just took the same presentation that I made 1 month ago in Brazil, because I was invited also for a lecture, so I made this presentation for this lecture in Brazil. So the title is Integration of Soil Saprolite Continuum in Soil Classification Systems. So First of all, I think it's important to define what is soil classification. So Daniel Allen defines soil classification as the process of arranging characteristic soil horizon sequences or soil features from the surface to its lower boundary into defined groups to facilitate their study, use, and identification. This is the purpose of soil classification. And in fact, when you look into definition, either in WRB or in soil taxonomy, you know that defining soil is very complex. It's a complex system with minerals, organisms, and so on. And putting its lower boundary is always tricky because it's a continuum. So for mapping purpose, both WRB and soil classification have defined the soil object that we classify as the 2 first meters. So we just put an arbitrary limit at 2 meters. But you know in the tropics that the soil can be deeper than 2 meters. But for classification purpose, for make maps, we put this at 2 meters depth. Here you have a nice picture of a soil from my friend Stefan Dondain in Belgium. He gave me this nice picture. It's an archaeological site in Belgium. So by putting this limit at 2 meters, we have this object that we classify as the defined soil in classification. But in fact, what we do most of the time is that we are classifying the first part, because the diagnostics that we are looking to classify are most of the time in the A or B horizon. The C and R layers are disregarded most of the time in classification. So we have a kind of gap, because those 2 layers, C and R layers, are that I call here subsoilum, at either saprolite or rock, result rock or whatever, are not really defined in terms of diagnostics in both classification systems. My reflection about integrating this into classification start after to have read this very nice paper from Fizoki and al. And as I just quote some sentence, you can see that in this paper entitled Soil Survey, A Window to the Subsurface, they state that a wealth of subsoilum information, including characteristics of the soil to substrate transition, is observed during soil surveys. But often these informations are not really well described or noted or recorded by soil scientists focusing on agriculture or agronomical purpose. So those information should be documented and retained during the process of soil survey. And soil survey should transmit a clear image of the understanding of both the soilum and the subsoilum. As I have a background in geology also, it's important that soil scientists, pedologists, or mappers should discuss with their colleagues in geology, especially surfacial geology, quaternary geology, because they can give a lot of information. In Luxembourg, I made a study, and I have my first paper is a correction of a geological map, because I made many soil survey in a place, and I found that the geological map was wrong according to what I discovered by observing the subsoilum. And I corrected the geological soil map. So it's important that soil scientists and geologists share and discuss together, because they can help. Here I just show you 3 examples of Luxembourg soils. And this is another reason why it's important. Because I study with hydrologists. So hydrologists told me to describe soil and to make some measure in soil for hydrological purpose. So here you have an example of tree soil. And to the left, it's pot soil developed on sandstone. In Luxembourg, the second, it's on slate or schist. And to the right, it's on marls or clay stone. And the sketch, our mind sketch, this is a conceptualization of the runoff processes on those soils and substrata. So it's important to see that the C and R layers have an impact on the hydrology. For example, you can see here the slate, there is a lot of cracks and the water goes in. I will show that in another slide. Here also you can see that we make some soil pit in Luxembourg sandstone place, so where we have agriculture, maize and so on. And in this pit you can see that the R is at 60 centimeters depth. And if you use this, and when you do soil survey with the auger, you will hit the rock. And you will classify this in WRB as Brunig District Regosol and put a continuous rock at 90 centimeters, or lytic contact in soil taxonomy. But surprisingly, when you pass this layer, you have this. So below this rocky layer, you found sand and weathered sand with clay coatings. It's not a B, but it's a C with clay coatings that I call a CT. The structure is not a soil structure. It's really sandy and saprolite structure. So you have a layer of rock, and below it's loose and some sand and clay. So it's a CT, and below that you have a R. So what do you do with this? How do you put this in your database? How do you classify this? How do you integrate this? This is the question mark. So in Luxembourg, I was also in charge to develop the database, and I integrate, this is the description sheets of our soils in Luxembourg, and I start to integrate into the C and R layers the rock aspect. And for example, I put fragmentation of the rock, the bedding and cleavage to inform about this. All these cracks, it's the cleavage of the slate. And the joint abundance, joints means the cracks that you have, and the aspect also for ecological purpose, because you can have some cracks. So here, for example, joint abundance, you have few, numerous, many, but the aspect is important for agriculture and ecology, because those cracks can be open and clogged with fine materials, or they can be open and prospected by roots. So also into these R layers, you can find roots. So those layers are important for forestry, for example. Here it's in the same place. So you see this soil profile, and one PhD student was doing sprinkling experiment on this slope here. So we apply a lot of water by sprinkling, and to see where the water is going. And according to my colleagues in hydrology, they expected to find that the water will follow the slope and to find water in the creek here. But with my experience and knowing the subsoil here, I took the orientation of those cracks. I measured them. So they are constant in the whole basin. And I explained to them that the water will follow the cracks, and the water will not follow the slope, but will follow the cracks and go at this place, more or less. And this is what they found. So I found it by experience, but they clue it, or they prove it by the sprinkling experiment. Then the water was passing the soil here, the first part, and following this schistosity and go there. So all of this was published in this paper. So all of this to show you the importance about taking information about subsoil, also for eco-hydrological purpose, and even hydrology, eco-hydrology, forestry. So now I'm going to the core of the topic. So in fact, the reflection about classifying subsoil was made in US during this during this World Regolith Pedology Symposium. And there was a first attempt by Buol in 1994, and he made a Saprolite regolith taxonomy. And to the right, this is my proposal that I made in 2016 about subsoil reference group. So this is the paper that we made with my colleague Stefan Dondain, also is included into this study. So the Saprolite regolith taxonomy is based on four categorical hierarchical levels: alluvium, colluvium, petrosediment, and saprolite. It classifies earth material or weathered rock below soil and above the hard rock. It's based on measurable properties. The names are similar to soil taxonomy, and they maintain the current soil classification system. So you can combine your US taxonomy and this regolith taxonomy. And mine, so the subsoil reference group, there is also first level of categorical details. It classifies also earth material and rock from weathered to fresh under the soil, based also on diagnostic materials. There is a second level of details with the qualifiers, like in WRB. Then the name are similar to the WRB and also maintain current soil classification system. So I try to simplify the key of Buol, but it's not so easy. So just quickly, so the key of Buol is based on mechanical properties. So the unconfined compressive strength is very important. So here, the unconfined compression is growing, and it defines two levels. A first level where you have alluvium and colluvium here, and a second level where it defines the petrosediment and the saprolite. So petrosediment is soil material hardened or cemented by pedological processes. And the second is inverse, I mean it's the bedrock that has been altered to saprolite. So it's a second level. It's the second line, sorry. And this here, until 25 megapascal, you can dig it with hand tools. Above, you need a machine to open the rocky material or the cemented material. And like in US taxonomy, so you have second level and you have the name, the strange name of the US taxonomy are coming also here with a combination of, for example, for alluvium, so you have a als, an on-als, an on-als, an edels, an erets, and so on. This is very complex. To be honest, I'm not using it because I developed my own that I will present to you. So my classification system is based also on four subsoil material that I call regolithic, saprolithic, paralithic, and lithic. And the structure is analogous to WRB. And you can have integrate. So all the profile can have integrate, so you can put those integrate. So we'll present you briefly the different materials. So the regolithic materials, it represents, so the idea is that when you have a soil in WRB, you enter the classification in soil with the cambic horizon, when the structure of the soil is dominant on the rock structure, so more than 50%. Here it's inverse, so we are looking at materials where rock structure is dominant compared to the pedic structure of the soil. So we classify the regolithic material is defined by a rock structure more than 50%. The soil structure is not enough to enter the cambic horizon. You can dig it easily with a spade, and basically, to be clear, it represents more or less all material deposited by water, like alluvium, colluvium also, wind, like loess, etc. Saprolithic material, it's all the materials that are coming from the weathering of the rock. So it's an in situ weathered rock. Also here, it's all materials that have more than 50% of rock structure, not enough to enter the cambic horizon. They can be dug with a spade. And so basically here it's an example of a weathered granite. It will be a saprolitic material. Paralytic material, we start to enter the materials that are harder. So in the paralytic material, once again, it's still more rock structure than pedic structure, but here it's materials that are difficult to dig with a spade. So you cannot really dig it, they are too hard. You can maybe take out some materials in the cracks, but not more. So it's difficult to dig with a spade, but you have signs of weathering, weakening, like the cracks and material infilling from above into those cracks, like in the pictures. And also, it's important that you have roots in the cracks. So it's basically fractured rocks with roots in cracks. And the lithic material, here it's what we can say is more or less the bedrock. So here the rocky material is dominant. You have more than 90% of rock structure. It's very hard to dig. You cannot dig it with we cannot dig with spade, sorry. And there is no roots because roots cannot enter into this material. So a simplified key. I don't know if you are used with soil classification and WRB, probably not, but quickly in WRB and in my system, diagnostic materials give you a preferential subsoilum group. So if you have a dominant regolithic materials on more than 75 centimeters, you will define a regolith subsoilum group. If you have a dominance of saprolitic material, you will define a saprolite reference group. If you have dominance of paralytic, it will be a saprock. If you have a predominance of lithic material, it will be a bedrock. And here I will present you 4 profiles from Brazil quickly, because it's complicated. But so some two first profiles are coming for the northeast of Brazil, of Pernambuco states, in tropical humid semi-arid climate, plutonic acid to intermediate rocks, and 2 profiles in the south, also in subtropical humid climate. So the first soil profile is this one. So to the left, you have the soil taxonomy and the classification of subsoilum by Bruhl, and to the right, you have WRB and my proposal of the subsoilum reference group. So quickly, so for Bruhl, you will have a granidap. So the soil will be a lithic udortens, but the below material, the subsoilum, will be a granidap. It's a nap because it's a saprolite. It's a need because you can dig it with a spade. It's a gran because feldspar and vertite are present and alterated. And it's a granite because it contains quartz. So at the end, you obtain a granidap. So you have a lithic udortens over or with granidap. If you use my proposal, in WRB, you will have a neutric regosol loamic bathyscholitic. But looking at those layers here, especially, you can see that you have saprolitic materials, because all these are saprolitic materials. So it will define a saprolite reference group. Saprolitic materials dominant, so saprolite reference group. Then you can add the secondary level of classification with the qualifiers. For example, here the texture is sandy loam, so it will be loamic. You have some roots that you can see here in the matrix, it will be rootic. And you have a lot of coarse materials, so it will be squeletic. And at the end, very important also for me, you can add these qualifiers for the lithology. So in database, you can put it. So at the end, you will have a neutric regosol loamic bathyscholitic for WRB over an aplic saprolite loamic rootic squeletic granitic. Quickly, the other examples. So here it's Bruhl. Once again, so we will not go into the detail, but it will be granite granarap with a lithic ustortent. And here for my classification, as it is a cyanide. Here we have two different materials. You have saprolitic materials here, the C here, and you have paralytic materials, so R, that represent this part here. So here you can inform both. So the dominance of saprolitic material define a saprolite subsoil group, but the fact that you have paralytic material here will be informed into this qualifier. I know that it's very complex for people not in soil classification. That's why I will not go in too much detail. But at the end, you will have an applied, saprolite, continuic, phaneritic, rhotic, bathyparalytic, diuretic. It's the same for this one, so I will pass also quickly. So here, what is important is that it's an intergrade. Sorry. So you have two different materials, saprolitic material for the C layer here. This is saprolitic material, and paralytic material from this part here, R1 and R2. So you have an intergrade, and you can put it here. In fact, the majority, sorry, I made a mistake. It should be lithic and not paralytic. So the lithic materials here, with no roots and too hard, will define a bedrock, and you can put saprolitic because you have this saprolite here. So at the end you have, here, lithic material, R2, defined bedrock. And at the end you have a paralytic, saprolitic bedrock, aphanetic, continuic, and rheolitic. The last profile, so quickly, so it will be a brecciated volarab for buhl. And for me, I define paralytic materials into this part because I can find some roots into the cracks. So this is the dominance of paralytic materials defined as saproc subsoil group. It will be applic because you don't have intergrade, and you can put this as secondary qualifiers. It will be applic, saproc, aphanetic, continuic, rhotic, and rheolitic. So at the end, what we have is that the saprolite taxonomy of buhl give emphasis on geomechanic properties, and knowledge in geology is needed for buhl. It's a closed hierarchical classification system, and for my proposal for the SRG, it's based on observation on soil structure versus rock structure, the occurrence on roots. So it's easy to see if you have roots or not, so it permits to distinguish paralytic from lithic, so it's easier for people like you learning soil science than to go deep into geology. You don't need specialist knowledge in geology. You don't need to make unconfined compressing strengths in laboratories. Just look at your profile. You can put a lot of descriptive details like the texture, the crack orientation, the roots, that are relevant for ecological, hydrological, or other environmental functions. And qualifiers are thematically grouped to facilitate handling and searches in database. And it has a WRB-like structure with the advantage of being an open classification system. Just quickly, I made this publication in 2016, and in 2018 there was an internal classification congress in South Africa. And after that, I have seen that Africans, so the South Africa expanded their classification into 4 horizons after integrating my ideas. They didn't use my proposals, they adapted to their context. So they create new horizons. They create a saprolitic, geolitic, graditic. The other one is missing, I forgot it. But they create new horizons for subsoil. So they integrate it into their classification system for South Africa. And also the new edition of the WRB propose my system, so it's official in the WRB. If you go into it, you will find that they propose to use my system to materials below the diagnostic of the WRB. What they also do, the working group of the WRB also define a saprolitic material that was not present before based on my proposal. But it's not exactly the same. Anyhow, the importance is that my works start to influence and to be integrated into soil classification system at the international level. And of course, it was with my Brazilian colleagues, so I thank you for your audition. Thank you so much. Maybe if you have some questions, I'm open.
Okay, any question? Kalau ada yang tanya nanti mau dikasih hadiah sama Pak Ma'ruf. Nilainya bagus itu. Okay, any question? Please raise your hand. Ayo. Kok silent semua?
It's too complex. I will have questions in few years when they have to maps or to classify.
Yeah. Gimana? Lah ya, apa? Boleh nih apa bahasa Indonesia boleh. Bahasa Inggris ya bagus kok. TOEFL-nya tinggi-tinggi. Wong tanah. Ayo, come on. Boleh tanya bahasa Indonesia. Ayo. Ya, oke. Kenalkan namanya siapa. Oh gitu, oke.
My name is Surya Aditya. I just want to ask something. Is there any specific information or like about like climate or anything before you dig some profile? So before you dig some profile, you search about some specific information, or you just
Of course, I look at the geological maps and geomorphological maps before opening the profiles. But honestly, in fact, the geological maps are, when you do soil science at the scale when you work, often the geological maps are wrong. So if you are at the border of some geology, you have always either covering by new materials like colluvium, if you're on slopes, and often you have to, that's why I think it's very important for soil, when you do soil mapping, really soil mapping, you need also a good training in superficial geology. What I see is when I am, don't take it as don't want to pass like arrogant, but when I am, for example, in excursion for WRB, I am always not happy about my colleagues because I'm coming from geology and I see lithic discontinuities more than them. So often. So I often disagree, and with Stefan, most of the time we agree. Stefan has a good training also in superficial geology. And often people coming, we are not in agreement with them. That's why during the WRB excursion, we have, like always around the soil pit, a lot of discussion. So for me, it's important for students. I don't know how it works for you here, if you are doing soil science apart from geology, or if also some geologists are coming with you. But for me, it's like a coin. One face is pedology, the other face is geology. And if you want to understand, you need to be trained in both to correctly understand your profile. some people are missing a lot. Geologists also are doing mistakes. I have seen some geologists in the Paris Basin, for example, sedimentologists seeing at quarry profile where you have white sand, black layers, white sand and calcrete, and they say, okay, the white sand, it's sand, white beach. And the black one is lignite. It's deposit of carcass or whatever. They see it like deposit. But if you are here with training in soil science, you see giant podzol. You see the white is a big E horizon. Here's our BHS horizon. You understand my? So geologist needs the soil scientist and inverse. And I am worried about the fact that, you know, pedology was first called agrogeology. So this science is born in geology. And so geology evolves here, pedology here. But too far away. Now we need to reconverge a bit because here we have so much questions that we need to exchange. I explained, for example, I was in Brazil and there was vertisols. And one profile, I recognize the profiles looking like a profile that I have in Luxembourg that I have shown you. And there is slickened side, of course, in vertisols. But if you look at what we call bedrock in soil science, you can see slickened side in the bedrock. In fact, it's a very old paleosoil that became the rock that is reactivated at the surface. So it was a Triassic paleovertisol, now cropping out at the surface, and it's reactivated. So the old vertisol is now working again. And you see slickened side in hard, what you will call bedrock, but if you look in, you see the slickened side not working anymore. But those that are being at the surface are working. You understand my meaning? So it's a paleovertisol. It's not a rock, but when I am with my colleagues from agriculture in Luxembourg, they consider it as a rock, and I consider it as a paleovertisol. You understand? So you have to learn a lot by yourself. If you are interested by understanding a profile, pedogenesis, you have to learn a lot. Your professors are there, of course, but you have to be a good observer. You have to visit the place. You have to combine all this information by yourself. Thank you.
Oke, jelas tadi. Jadi ilmu pedologi dengan geologi seperti koin yang satu sisi ya. Jadi makanya kalau di kuliah saya mengatakan geologi itu mbahnya ilmu tanah ya. Jadi makanya harus selalu basic dari pengetahuan ilmu geologi itu menjadi sangat penting ya. Makanya di mata kuliahnya Pak Ma'ruf yang terkait dengan ban induk itu menjadi sangat penting ya. Jadi di lapangan itu sering terjadi ada persepsi yang berbeda. Jadi tadi beliau cerita di Brazil ada vertisol tapi yang sudah lama. Itu disebut dengan paleovertisol gitu ya. Beberapa orang mengatakan oh itu sudah jadi batu. Ya, ternyata beliau katakan itu adalah paleovertisol yang sudah lama. Ini sangat menarik. Oke, silahkan yang menarik. Oh ya, boleh.
Okay, my name is Francisco. I'm a second-year student of soil science. I actually want to say thank you to Mr. Jerome because your presentation is actually super good and interesting. But it's actually too complex for me as a new student because I love a simple thing, Mr. Jerome. Okay, so I have two questions. My first question is what kind of a starter pack for me as a new student to studying pedology? And then my second question is, why is saprolitic material not enough soil structure for Cambic? Even though if we look, saprolitic comes from weathering, we call in situ, which contains minerals where the materials for soil structures are minerals.
So the second question, so what is saprolite? Because you are speaking fast and I...
Okay. I'm trying to say slowly. In the screen,
Yes.
there is like a character of Saprolite.
Yes.
Okay, that contain that Saprolite. It's not enough
To become big?
Yeah,
Yes.
to become big.
Yes.
We know that Saprolite is by wedging that we call in situ, right?
Yes.
There is mineral, and mineral needs for come big.
Yes.
Why it's not enough? That's my question.
Why this rate? This rate? Can you repeat the last?
Oh my God, I'm shy.
Oh, maybe I can look. Okay, so Sapolitic, it's not come big because my purpose is to classify what is under the classification covered by the WRB. In WRB, if your soil structure rise 50%, you can start to classify in the soil. Below, it's not considered. So, but when you are in the field in a pit, sometimes you have saprolite and you see beds developing in, but not enough to be a real horizon. So you will put C instead of B, for example. You understand? So it is to classify this gap, because when it's a B, it's clear, but when it's between, you can put C in your description sheet, but it will not be considered into classification. Because you have to combine also the fact that we are combining WRB and below. So what is covered by the WRB, it's okay. If the 2 meters are covered by the WRB, you just use WRB. But if, for example, you have a rego soil, so very shallow soil, you are in fact classifying just the beginning of the soil, and the rest you are not considering it in the classification, because we say that we are classifying 2 meters. Okay? So of course, if you have 2 meters of podzol, it's a podzol. That's it. The story is finished. But sometime in a hill or in other place, you have diagnostics for in the first meters and not in the downer part. So if you have regosol or leptosol or rocky soil, you just need 25 centimeters of soil and the rest is rocky. So you say it's a leptosol, but what about the rest? What about the information in the rest? Like the cracking that I show in the image. So you will just say it's a leptosol or and that's it. So my classification is to cover this gap, to classify also the more rocky part, I will say. Do you understand?
A little bit.
And what kind of understanding do new students like me most in studying pedology? Field. Go to the field and look and map and observe by yourself. If you are passionate, you know, when there is an outcrop, you are always going, what's that? This is how I works. And this is my advice, is you have to be passionate and you have to learn by yourself a lot. Of course, education is to the basis, but your passion and your love for nature and understanding will help you. And don't be always on your screen. Go outside and do a field trip.
Okay, thank you.
Oke, ada lagi yang ditanyakan? Oke, belakang. Sip. Jadi kita tidak hanya bicara 2 meter, tapi di bawahnya itu juga penting. Ya.
Okay, my name is Aditya Rizky Wijaya. I'm from class 2021. So my question is, you explained about SRG already as one of soil classification in the world, and you have a sample in Brazil as your example, and as we know, Indonesia have many similarity in climate and in soil as in Brazil. So if I want to do some research or observation here in Indonesia, can I use SRG as my source of, classification method?
Yes, you can use it. Yeah, yeah. I mean, my proposal have been used mainly by Brazilian colleagues. So if you look to Subsolum or look for papers, you will see that Brazilians are using it. I am still in contact with people working in Saprolite in Brazil for developing these topics also in Brazil. But of course, if I made this proposal and publication, is to use it, and I would be glad that people or some students would like also to use it in their study and to see in mapping if it also works, because the key is not locked. Of course, if there is, you can improve it, like in WRB. When you do WRB excursion, we are always improving the key. That's why you have many updating. So it's the same. If you consider that this is not good for your country, you can say, okay, this, I would like to change that. So I make my own proposal. But you can have my email address, and you can send to me, and we can look together. But don't be afraid to change the things. So you say, okay, this is okay for me, but I would like to adapt this and make your own proposal. You have to propose also. This is how it works, in science. So propose and think about and propose your own key. No problem, of course.
Okay, thank you very much, sir.
Oke, silahkan. Ada yang lain? Wah, sip. Tadi saya tunggu-tunggu yang wanita kok belum ada yang tanya.
Thank you for this opportunity. I'm Miftah, and I want to ask about, maybe it is out of the topic. So recently, I read some article that is the role of soil from SDGs to achieving them, and most people doesn't really familiar about how the role soil to achieving SDGs. So, what your opinion? How soil from your classification to improving SDGs? Thank you.
So it would integrate the USGS taxonomy, you mean? Because I didn't get completely your question. It's not clear for me.
Oh, yeah. So what do you think about how soil can... How soil?
How soil?
Yes. How soil can...
You mean your soil here in Indonesia?
Yes.
Okay.
So, what's your opinion about the role of soil to achieving SDGs?
The opinion of your soil in the US?
Yes.
So the soil taxonomy.
From this article, that agriculture and consequently soil are the heart of SDGs and are fundamental toward achieving them.
I don't get it. Maybe I should read.
So, bahasa Indonesia ya. Jadi tanah ini merupakan basic dari gimana cara kita untuk improve SDGs Sustainable Development Goals, dan banyak orang belum familiar gimana soil itu berperan dalam meningkatkan goals dari SDGs tersebut. Nah, itu bagaimana?
Okay. This question about how the role of soil in sustainable of agriculture yeah, agricultural stimuli.
The use of this.
Yeah.
Oh, it's hard to say because it's not directly
Yeah,
connected.
we have concept about sustainable development goal. So how the role of soil in sustainable development goal in Indonesia? Yeah.
I think this proposal is important to what I call the forestry, or where you have soils developed on the slopes and rocks, and that are not really well covered by the classification, actual classification. So as you have seen in the example, sometimes you have very rocky material with a lot of cracks. So this will be classified as not developed soil, but the cracking in the rocks is very important in terms of water content. So for forester, for example, it's important to know place where the rock is cracked and where the water is stored. But to be honest, to respond directly like this is complicated. Its topic is classification for maps. And the direct link is not so easy. You find it when you study and say, okay, this place, I have rocky soils, but there is some a certain amount of cracks where the roots can go. And in this place, there is rocky soil without cracks. So here we can plant trees, but here we cannot plant it because they will not grow. So it can be one of the impact. But it's hard to explain like this.
Oke, paham? Jadi harus spesifik, ya spesifik. Jadi pertama kali peran dari pemetaan klasifikasi tanah menjadi penting, ya. Jadi nanti soil management ini sangat tergantung kepada karakteristik dari masing-masing jenis tanah, ya. Jadi di situ ada apanya tanahnya. Nah, saya kira nanti di kuliah akan banyak diberikan tentang pengelolaan, ya, kesuburan yang spesifik lokasi, ya, tergantung kepada jenis tanahnya. Sehingga ini peranan dari klasifikasi tanah menjadi sangat penting, ya. The role of soil classification in development of agriculture, ya. Oke, ada question? Ada pertanyaan lain? Oh, oke. Pak Andi.
Thank you for your nice talk. This morning we are glad that you are come here, as I think you are a pioneer, because when I type in Google subsolum classifications, the first one who comes publications is yours. So my question is, you are a pioneer in this topic, in this research, and you are proposing a new idea, I think, and which is not easy. It is hard to propose new things to the existing knowledge. So my question is, what is the challenges and how you face the challenges to propose your idea? And I think your idea is well accepted now. Yeah, thank you.
So you are right, it's hard to change mentalities. I am in contact with the WRB board, so as I have shown you, they start to integrate it, but I start this story almost 10 years ago. So it takes time. You have to go to conference like the one in South Africa. I was glad that South Africans were happy about that and start to change their classification system. They didn't use my proposal, but inspired by my proposal. Now the Brazilian also, if you look at in Google Scholars or Scopus, you will see that the Brazilian are citing me. So they are the most people citing me. And we are also, that's why I was invited 1 month ago. They invite me for this conference. So, of course, it takes time. You make a proposal, and like Biol made his proposal, but there is almost no citation. So he made it 30 years ago. But it was good, it was the first attempt, but it's too complicated. You have to measure the uncompressive strength, you need to go into the lab and so on. Mine is easiest because it's just field description if you spade, so it can do it quick. After that, you have to work on the fact that people should use it. That's the big challenge. And how is it important? So you have to convince people. Some people, like Brazilians, find it interesting. Now, I would like some people start to use it and for mapping, because at this stage it's just a proposal. We don't have a real maps proposal with my maps. So if someone want to use it and map, it would be the first to make maps based on my proposal. So with Brazilian colleagues, it's growing slowly. So we will see what happens. But yeah, when you are pioneer, or the first to propose, it's hard. And you have to convince people. Thank you.
Thank you so much.
Oke, silakan. Masih ada lagi yang lain? Ton, tanya Ton. Oh, pakai bahasa Arab juga boleh ini. You speak Arabic.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you. So I'm glad to you. My name is Nur Fatoni. I'm from the Magister of Soil Science. So I want ask you a question. In our country, many cases of soil development from transported material. This year's purpose can be used in soil that developed from transported material. He doesn't develop from the geological in situ. So he development from the other material can transported in one place. Is this purpose can be used to our classification? Thank you.
Yes, it can be used because it will enter the regolithic material. So all alluvial or ash deposit will be into the regolithic material. So if you have a profile, for example, of alluvial, you will classify it as a fluvial, for example, but down it will be a regolithic, fluvic regolithic material. So this can be used, or for ash deposit also. So you will be also regolite subsoil group.
For then, when the rock under that this soil can develop it, so how we to classify the regulate or saprolite? Is this material we classify it from the transported material or in situ rock material?
Yes. So you have to define if it's transported, or first to know if it's transported or in situ. So this you need your own knowledge when you are in a profile, if it's in situ or if it's transported.
Oh.
So if it's in situ, if the base of your profile, for example, is basalt,
Yes.
weathered basalt, it would be saprolitic material. And if it's covered by kind of alluvium of slope deposit, this material will be regolithic.
Oh,
Okay?
yes,
So we have
okay,
regolithic
okay.
and saprolitic. And you look at what is the most important. The most important, we define the group. If it's the saprolitic, it will be a saprolite in the classification. But the regolithic will be a regolithic saprolite. So you know that it's covered. So it's a saprolite covered by other material, regolithic saprolite.
Oh, yes, okay, okay.
For the intergrade, what I explained. So you can put intergrade. Okay?
Okay,
Yeah,
thank you.
You need to be informed with photo and
Some
description.
photo, yes, okay, so thank you.
Okay. Any question? Dan, apa Dana ini di belakang itu? Tanya Dan. Ini di belakang. Ayo, penelitiannya bisa ditanyakan itu. Takon.
Thank you. Hi Jerome, my name is Padana Barus. We in Twitter we always some chat and some experience with your photo. I admire your work, and we together in our Twitter we always chat.
Nice to meet you.
Nice to meet you, Jerome. So maybe what I want to know, what is your next? We have you have this proposal, and what is next? I also see your work about humusika and what your micro
yes, I was involved
micromorphology. So what is next? And how to can you give us what is your pengalaman apa ya? Yeah, experience when you are a new student, or what is your first why you choose pedology? You are the geology, you are in geology, and now you choose pedology. What drive you to learn about pedology? I just want to know about that. Thank you.
So what I would like to learn more,
Yes.
I think basically I'm defining me like a geoscientist. So when I have with soil scientists, I'm happy to do soil science. With geologists, I do. If I go with archaeologists, I will also do archaeology, because I'm a field man and I am a good observer. This is where I am good. If you speak about modeling or database, this is not my trick. I let you for the young generation. But in the young generation, you need also field people, because otherwise you will lose the way to well-describe soil, and this is important. So actually, maybe I'm always out of the box. So that's maybe my problem or my quality, I don't know. But now I'm interested to classifying moon soil. So this is the next topic on which I'm working. I am in contact with also pioneers from Italy, like Professor Giacomo Sertini and Riccardo Scalenghe, that they were the first to publish a paper in 2009, Do We Have Soil Out of Earth? It was a very critical paper, because some papers are sticking of Dokuchayev dogma of biota to define soil, but I am among those heretic people that consider that you can have soil without biota. So, because soil forming factors, you have parent material, climate, biota, and so on, but you can reduce one. If you don't have biota, you have the others, and you can have some soil. It's not soil in the sense of Dokuchayev, but it's a soil in the lens sense. When we are speaking about people to soil, it's where we are stepping. So if you are interested by Mars and Moon, and when you look at data, you can find horizonation. So you can find processes like removal, erosion, maybe kind of translocation. In the Moon, you have special particles because you have micrometeorite producing what we call agglutinates particles. When you look to the Moon, the system is that you have finer material at the surface and coarser below, because you have comminution by micrometeorites, so that reduce the particles. So if you have sand, after some million years, it becomes a silt, just by the bombardment from solar winds and micrometeorite. So you have processes that are similar to pedogenesis, not the same, without biota, but you have a kind of horizonation. So now we are looking for that. I presented a poster 2 months ago with a colleague in Italy, in the Moon Symposium, where we make a first proposal for moon soil. In classification, I'm speaking about classification. This poster is available if you go to my ResearchGate or whatever, you can find the poster. This is the next step where I'm looking for.
Thank you, Jerome. I appreciate your work, and I think that's why I always follow your tweet, because you seek for the universe, and I admire your work. But one question, this is the last question. You know, our in soil science that pedometrics is now hype. We call it soil digital mapping, and we use mathematical equation and another data, big data. But what about your opinion about this trend? Do you, as a fieldman, think this is the new wave or the new thinking about soil science?
Now, of course, I think it's important, but it should not be only this. I mean, both are important. And maybe the lack of communication between both communities is also problematic. I know that, you know, in the IUSS we have those groups, so classification, pedometrics, micromorphology, and so on. But we are not so exchanging. So pedometricians should also maybe be invited or come with, for example, classification. And we should maybe share more, because they are doing based on their data. So for them, it's okay. In a mathematical point of view, modeling point of view is okay. But when you go into a soil profile, you know, oh, it is complex. It's hard to make the link. So it's important, but what is more important is to be or to have some people training into both. Not only a field guy like me and data scientists. You understand what I mean? We need people that are able to do both. That's to really understand and to be able to, when you do your digital soil mapping, to know what is a soil profile. Because some people are treating data, also in hydrology. I don't know so much into pedometricians, but maybe it's possible. I don't know, but people are working on pedological data without knowing what is a soil profile. It's possible, I think. I have seen people working in hydrology, doing modeling in hydrology without knowing how to measure discharge in a river. So this, for me, is strange. You understand?
Yeah.
So I'm not against. It's not my trick. I don't know. I'm not into this. But I will be happy to work, for example, with people and to share with people doing that we can have a common language and exchange. So this exchange is important, and the field should be maintained also. Thank you.
Thank you, Jero.
Oke, ada yang mau bertanya lagi? Jadi tadi ada satu disiplin ilmu baru ya di bidang ilmu tanah, itu namanya pedometrik. Jadi yang suka ngutek-ngutek persamaan matematik, gitu. Ada yang suka. Biasanya orang tanah malah takut matematik ya. Ya, itu pedometrik sangat menarik itu ya. Boleh itu yang kalau mau belajar mendalami. Ya. Silakan, ada yang lain ingin ditanyakan? Oke. Sip.
Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. For Mr. Jerome, thanks for your presentation, and it is mesmerizing us and give such a good study about Saprolite Continuum in soil classification. Maybe my question is a little bit out of this context. As long as you travel around the world, like Brazil, South Africa, and also your own country, Luxembourg, and maybe you have such research on Indonesia, what is unique things you find as long as you do research? Thank you, sir. Maybe.
Just repeat, maybe speak not too close.
Okay. What is your most unique things you find as long as you research maybe such a good and new research for the future, sir?
So the unity.
Yes.
So the classification. Yeah. For me, the classification topic is the unity of all this research. Also involved into humus classification, and for me. It's not possible to classify what I call a regolith profile with one system. You need the three systems. You need to classify humus, soil, and subsoilum to have a clear view about a profile. Because the humus can change in 1 year. If you have new earthworms coming, or you are cutting all the trees, you can change the humus in 1 or 2 years, your humus system. And so the time are different. The humus, 1 to 2 years you can change. The soil, it takes 1,000 years. And the subsoil it takes 1,000,000 years to change. So the time are different. And for have a clear view, you need to use humus classification, soil classification, and subsoil for me to have a clear view about all the system. So this is what they call wall-regolith pedology. Yes. So the unity is the classification, how to be able to classify and to name our profiles.
I think that's all. Thank you for your such a wonderful answer for me. Thank you very much, sir.
Thank you.
Okay, let me introduce myself. My name is Jason Kurniadi, and as we all know, maybe you have done a lot of research. Either it's from your geology major or maybe your pedology major. So my question is there any research that maybe you haven't achieved yet, or maybe the goals that you have trouble in it? Those are my question. Thank you.
So once again, repeat because.
Okay, sorry. So, as we all know, maybe you have done a lot of research. Either it's from your geology major or maybe your pedology major, isn't it? Okay, so is there any problems on your research, or maybe is there some research that you still touch that goals? Yeah, thank you.
Honestly, as I explained in the introduction, most of my task is not this. I'm working as an engineer. As I will re-explain, I don't have a PhD. I just a master, okay? But most of my time I'm maintaining and collecting data into critical zone, basin, and networks and so on. So this research, I made it on the side. So that's why, I'm almost 50, and I published my first paper as, 35, something like that, without PhD. But slowly I said, okay, this topic, I like it, so I start to publish on it. So I didn't make so much research. I just have the opportunity to be in the WRB working group and enjoying to go into the world and to classify. So I start to classify with those people. But I don't have made so much research. Most of my publications are made with as co-authors with others. So okay. So, but myself, when if I am with archaeologists, I will learn archaeology. For me, it's natural to learn, and it's always the soil, the rock, and so on. But it's not real research. I mean, with credit. So if it can be inspiring for you, I'm glad of that. But you see, I'm not PhD, just master. But now I'm doing conference in the world. So, alhamdulillah.
Okay. Thank you. That's such an inspiring answer. Thank you.
Oke, ada? Silahkan. Ya, beliau banyak pengalaman, bisa dieksplor keliling dunia, ya, dari berbagai negara. Silahkan. Ada juga loh alumni kita yang sekarang ngetop, ya. Di mana? Pas Piala Dunia terakhir, nah itu yang ngurusi rumput itu alumni kita loh. Sekarang jadi ngetop. Oke, any question? Gimana Pak Maruf? Cukup? Enough? Okay, thank you very much, Mr. Wandi, for your lecture. I think this very, very valuable lecture, and I think you can give some idea concerning classification and substratum. This is important point for our field, yeah, in soil science, especially for in pathology. Okay, thank you very much, Mr. Mahdi. Okay.
Thank you so much.
Give me applause.
Thank you.
Okay, there is special gift from Department of Science, and I hope Prof. Benito, as the head of lecture, to give.
Thank you so
Mr.
much.
Mahdi.
Thank you.
Foto. Kameramen, nggak ada yang. Biar nih, foto ini.
Thank you so much. Thank you.
Okay, I think we can make picture together with the. Loh, kok orang pikir ini fakultas pertanian ben kita gitu.